Hi everybody, I am Dr. T. Miranda Lakshmi, working as an assistant professor in the Department of Computer Science, St. Joseph College, Cuddalore. So in the last class, we saw about what is by memory management and what are the types of memory management, that is real memory management, and what is by virtual memory management, and what are the types in this real memory management, that is contiguous allocation and non-contiguous allocation. So under contiguous allocation, we saw about single contiguous allocation, fixed partition memory management, and variable partition memory management. The next one is your non-contiguous allocation. So under a non-contiguous allocation, we saw about paging, segmentation, and combined system. So today in this class, we are going to be in detail about what is by single contiguous memory management. So which operating system support this single contiguous memory management? This we can see it later. First, what is by single contiguous memory management? So if you're going to take this memory location, see here, this is your physical memory. Okay. So whenever you're going to draw a physical memory, it will be divided in two parts, because in one part you will be having your OS, that is your operating system. Your operating system will be present in one part, and the other part is your user part. So here your main memory, or you can say it as a physical memory, is being divided into two parts. This is a single contiguous. Single contiguous, I already told us what is my contiguous allocation means. We'll be having only a single partition. Only one partition is here. So whenever a new process arrives, it will be swapped in and it will be processed by the CPU, and after that it will be swapped out. More than one process cannot be executed in single contiguous memory management. So this is an example of MS-DOS operating system. In MS-DOS Microsoft Disk Operating System, we can execute only one process at a time. After executing that process has to be swapped out and the other process has to be swapped in. So the other things we can see what is present in this diagram. OS part starts from 0th location and it ends to fence register. What is my fence register? It is a register. This is the end point of your operating system. The last value of your fence register is your OS part. So whenever you're going to access it, the fence register part, before the fence register part must not be accessed by the user. After the fence register part, it can be accessed by the user, because it is the user part, that is the OS part. Must not touch the OS part. Now you can see what is my single contiguous allocation. So already as we have seen it, it has two parts. One is OS part, the other one is user part. So whenever we need only one process, already told that only one process can be present inside this main memory. If that process is being completed, if that process has completed its work, then a new process can be swapped in. That process has to be swapped out and a new process has to be swapped in. This is the main concept of your single contiguous memory management. So in the figure we have already told that the OS part is stored in the lower address and the user program is stored in the higher address. What is the disadvantage of this method is lack of multi-user facility. We will not be having multiple user cannot be accessing it. Next one is internal fragmentation. So in the last video itself I told what is by fragmentation. Fragmentation means if you're going to allocate for, let us consider that in this part a new process is arriving as 10K process. So let us consider this full user part is of 50K. 10K process has been allocated here. The rest of the 40K is being wasted. That 40K is being wasted in that partition itself. So only it is called as internal fragmentation. Fragmentation means wastage of memory. What is my internal fragmentation means? Here in this partition itself it is being wasted. So that in this method we are not having a different partition, because we are having only one partition, because it is a single contiguous allocation. So internal fragmentation is nothing but when you're going to have a partition, in that partition if you're going to have a wastage of memory, it is called as internal fragmentation. This is a disadvantage in this method. Next we are going to see how relocation address translation is done in this method. Here the physical address, that is which is the starting address, is being known because where actually the compile time is being started is being known So it is not necessary to do the relocation address translation. What is relocation address translation? We are going to relocate. Relocate means we are having the compile address. That is, we can say it's a logical address, and we'll be having physical address. Physical address is nothing but your main memory address. This address has to be changed. We have to change from logical address to physical address. This is not done in this single contiguous memory management. The next one is protection and sharing. So here obviously how this protection is being carried out is using two methods. One is protection bit method. The other one is fence register method. So first you can see what is my protection bit method. In this protection bit method, we will be having two things. Bit means you will be having 0, 1. So if the protection bit is 0, it means it is operating system part. If the protection bit is 1, it is user program part. So the user can access the user program part, but it must not, he or she must not access the OS part. So if the user tries to access with protection bit 0, it is not allowed because it is OS part. If he or she is going to access it with 1, it will be allowed because it is user part. This is the first method. Protection bit is the first method. The other method is fence register method. Already we have seen what is my fence register. See here, the fence register, here if you are going to have it, the starting from 0, and the fence register is the last address of your OS. So how we will be checking it? If a fence register value is less than, okay, if a user is going to have a value which is less than the fence register, then it is OS part. It will not be allowing to access. If it is more than the fence register, it is user part, because it starts from F. If it is less than or equal to your fence register value, it is OS part. It will not allow to access it. If it is more than it, then it will be allowing you to access it. It is your user part. So if you're going to take your fence register, so this is how it will be working. Protection. Sharing, there is no meaning of sharing because you're going to have only one process. So there is sharing is not possible in this method. So since only one process is allowed, sharing is not implemented in this method. The last one we are going to see about evaluation. What is my evaluation is what are the drawbacks and what are the advantages in this method. We are going to evaluate it. First one is wastage of memory. So already told that wastage of memory is relevant to your fragmentation. So here there is fragmentation, there are internal fragmentation, but even though if it is being wasted, it is of no use. We are not having multi-user facility. We are not going to use that memory to any other process because it is a single contiguous allocation. So even though it is going to waste large amount of memory, it is of no use. The next one is access time. So access time, it will be very fast because relocation address translation is not done. So when you're going to go in for your access time, relocation, when you're going to relocating your compile address into your logical address, that is your logical address into your physical address, then it will be taking more time. But here the relocation address translation not done, so the access time is very fast. The next one is time complexity. What is my time complexity is the process which you're going to take it from your hard disk and you're going to place it inside your main memory. How much time it takes for allocation and how much time it takes for deallocation. Deallocation is nothing but after the process has completed its work, we have to remove that process from the main memory. That is called as deallocation. So in this method, the partition is, we are having only one partition. So it is very easy to allocate and deallocate the memory chunks. Thank you.